Today we are going to discuss some practical problem, but first of all recall formula. First formula, n of A union B is equal to n of A plus n of B minus n of A intersection B. Second formula, n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. Third formula, n of A difference B is equal to n of A minus n of A intersection B. Fourth formula, n of B minus A, otherwise n of B difference A is equal to n of B difference n of A intersection B. Fifth formula, n of E dash union B dash is equal to n of universal set U minus n of A intersection B. And sixth formula, n of A dash intersection B dash is equal to n of U difference n of A union B. Now, in exercise 1.6, discuss question number 4 related to this formula. So here question is asked, if S and T are two sets. Here two sets is present, S and T. In set S, 21 element is present, and set T has 32 elements is present, and S intersection T has 11 elements is present. Our question is, how many elements does S union T have? So first of all, we can written here n of S is equal to 21, n of T is equal to 32, and n of S intersection T is equal to 11. Our question is, find out n of S union T. So here we can written n of S union T, find out. Now we know that n of S union T is equal to n of S plus n of T minus n of S intersection T. Now n of S value is given, number of element of n of S is given 21. So here we can written 21 plus n of T in place of written here 32 minus n of S intersection T 11. So is equal to 32 plus 32 plus 21, that means 53 minus 11. Now subtract this term, so we get 42. So here n of S union T is equal to, we get 42. Now next question, question number 5. Again here data is given. Here again two set is present. If x and y are two sets such that x has 40 elements, x union y has 60 elements, x intersection y has 10 elements, and our question is how many elements does y have? So here n of x has 40 element, that means n of x is equal to 40. N of x union y is equal to 60, and n of x intersection y is equal to 10 element is given. Now our question is how many element does y? So find out n of y. So again here same result apply. First of all we can return, we know that n of x union y is equal to n of x plus n of y minus n of x intersection y. N of x union y in place of written 60 is equal to n of x in place of written 40 plus n of y find out here, so we can written as it is, minus n of x intersection y is given here 10. So therefore 60 is equal to 40 minus 10, that means 30 plus n of y. Now plus 30 written in opposite side, so change the sign. So therefore 60 minus 30 is equal to n of y. So here we get n of y is equal to 30. Next question. Question number 6. Here question is given, in a group of 70 people, 37 like coffee, 52 like tea, and each person like at least one of the two drinks. How many people like both coffee and tea? So first of all here we can consider, let C be the set of person who like coffee, and tea be the set of person who like tea. So here 37 like coffee, that means we can return n of C is equal to 37. 52 like tea, so n of t is equal to, written here 52, and 70 people like coffee and tea, so n of C union T is equal to, we can written here 70. Now our question is find out how many people like both coffee and tea, that means n of C intersection T, find out. So again we know that uh, n of C union T is equal to n of C plus n of T minus n of C intersection T. So n of C union T in place of written 70 is equal to n of C, that means 37, plus n of T in place of written 52 minus n of C intersection T, find out here. So this term written at it is. So therefore 70 is equal to 52 plus 37, that means 89, minus n of C intersection T. Now n of C intersection T is here, negative sign is present, written in opposite side and change the sign, and 70 written in this side and change the sign. So therefore n of C intersection T is equal to 89 minus 70. So 89 minus 17, so is equal to, we get 19. So therefore n of C intersection T is equal to, here we get 19. Next question, question number 7. A question is asked, in a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? And how many like tennis? So here two question is asked. First question is how many like tennis. So first of all find out how many like tennis, and after second question is how many like tennis only and not cricket. So first of all, we can consider, let C be the set of people who like cricket, and T be the set of people who like tennis. So here we can return number of n of C, that means n of C 40 people. So n of C is equal to, written here 40. N of T find out here. So n of T find out. Now n of C intersection T. So how many people like both cricket and tennis? So 10 people like both cricket and tennis. So n of C intersection T, we can return 10. And 65 people in both the group. So n of C union T is equal to, we can return 65. So again, first of all, we can using same formula. We know that n of C union T is equal to n of C plus n of T minus n of C intersection T. n of C union T is given here 65 is equal to n of C 40 plus n of T, find out here, minus n of C intersection T, in place of written 10. So therefore 65 is equal to 40 minus 10, that means 30, plus n of T. Now 30 written in opposite side, so therefore 65 minus 30 is equal to n of T. 65 minus 30, so therefore here we get n of T is equal to 35. So here one question is over. How many like tennis? So we get n of T is equal to 30 people like tennis. Okay, now here second question is asked, how many like tennis only and not cricket? So now number of people who like tennis only and not cricket. That means we can find out n of T minus C, because the number of people who like tennis, that means n of T, and not cricket, that means minus C. Now how can we find out n of T minus C? That means n of T difference C. So again we know that this formula, n of T difference C, otherwise n of T minus C is equal to n of T minus n of T intersection C, and both this data present here. N of T already find out here 35 minus n of T intersection C and n of C intersection T, both are same value. So here we can written n of T intersection C in place of written 10. So is equal to, we get 25. So our answer is 25. Next question. Question number 8. In a committee of 50 people speak French, 20 people speak Spanish, and 10 speak both Spanish and French. How many speak at least one of these two languages? So first of all we can consider, let F be the set of people who speak French, and S be the set of people who speak Spanish. So now here 50 people speak French, so we can written here n of number of F is equal to 50. 20 speak Spanish, so n of S is equal to 20, and 10 speak both Spanish and French. The N of F intersection S is equal to 10. Now our question is find out N of F union S. So again here we know that N of F union S is equal to N of F plus N of S minus N of F intersection S is equal to N of F in place of written 50 plus N of S in place of written 20 minus N of F intersection S, that means here we can written 10. So is equal to 50 plus 20, that means 80 minus 10, so we get 70. So N of F union S is equal to, we get here 70 people. Sorry, 70 minus 10, so here we get 60. Okay, so is equal to 70 minus 10, so we get 60 people. Next question. Miscellaneous exercise, question number 30. In a survey of 600 students in a school, 150 students were found to be taking tea and 225 taking coffee. 100 were taking both tea and coffee. Find how many students were taking neither tea nor coffee. So first of all, we can consider let T be the set of students who like T and C be the set of students who like coffee. So here N of T is equal to 150 is present because 150 students were found to be taking T. So N of T is equal to 150, 225 taking coffee. So N of C is equal to, we can return 225, and N of C intersection T is equal to 100 student. Now first of all find out, we know that N of C union T is equal to N of C plus N of T minus N of C intersection T. So N of C, that means 225 plus N of T 150 minus 100. Add these numbers, so 375 minus 100, so is equal to 275. So N of C union T is equal to, we get 275. But actually our question is find how many students were taking neither tea nor coffee. So here number of student taking either tea or coffee is equal to 275. But neither tea nor coffee, that means therefore number of student taking neither tea nor coffee is equal to total number of student is 600 minus either tea or coffee, number of student taking either tea or coffee 275, so minus 275, so is equal to we get 325 people neither sorry 325 student taking neither tea nor coffee.